Hello and welcome to the next video in the series Excel for Finance. In this short video, we shall learn about valuation of annuity. What is an annuity? An annuity is a series of uniform cash flows occurring at regular intervals, usually every year for a specific number of periods. So the characteristics of an annuity is the amount occurring every year is same and it occurs for a specific number of years. We come across many instances of annuities in our real life, like recurring deposit scheme, monthly income plans, pension schemes, loan installments, insurance premiums, etc. For valuation of annuities, there are two important aspects that we have to keep in mind. First question is whether to use future value or present value of annuity. And the second question is the cash flow stream we are valuing, is it annuity or annuity due? Unlike the single amount case that we dealt with till now, where future value is equal to present value into 1 plus r to the power of n, we had future value as well as present value in the same formula. But that's not the case with annuity. So we need to first decide whether to use a future value model or a present value model. It is very simple. All annuity cash flows have two components. One is the uniform recurring component, and the other one is a bulk or a heavy component. In some cases, a uniform component will start now, and at the end of the period, you will have a bulk cash flow. In some other cases, the bulk cash flow will happen at the beginning of the period, and then annuity will continue. So this bulk cash flow is what we call as value of the annuity. So if the bulk cash flow happens at the end of the annuity, that means it happens in a future period, we use the future value factor. And if the bulk cash flow happens today, that is the beginning of the annuity, we use present value of annuity. Now let's come to the second question, whether to use annuity or annuity due. These uniform cash flows may start at the end of first period from now, in which case it is called annuity. If the uniform cash flows are starting today at present or beginning of the first period, it is called annuity due. When we take two examples, you will understand these two cases very clearly. Let's look at two examples. The first case is, I'm investing rupees 50,000 every year in a deposit scheme offering 9% interest per annum for the next 6 years. So here what is happening is, I start paying 50,000 from today for next 6 years every year. At the end of 6 years, I will be getting the entire amount back along with the interest. So here, the bulk cash flow is at the end and the uniform cash flows are starting today. Therefore, since the uniform cash flows are starting today, it is annuity due. And since the bulk cash flow happens at the end of 6 years, it's a future value model. Let's take the second case. I want to avail a loan from an institution charging 12% interest per annum and repay the same through 8 equal annual installments of rupees 60,000. In this case, I am getting the loan today, which means my bulk cash flow happens today and my installment payments of 60,000 every year starts from the end of first year from now. So since the bulk cash flow is today, we will use a present value model here. And since the uniform cash flow is starting at the end of first period or at the end of first year from now, we will use it as an annuity. Let's just summarize that. So case one, where I am depositing in a recurring deposit scheme, where my entire amount along with interest comes back to me at the end of 6 years. Since the bulk amount is at the end of the period, I use future value. And since the cash flow starts today, I use annuity due. In case 2, since I am getting the loan today, the bulk cash flow happens to be today, so I'm using present value model, and my annuity, that is my repayment, will start 1 year from now. Therefore, uniform cash flow starts from the end of one period. I'm using annuity. The formula for calculation of future value and present value of annuity are given below. Future value is equal to A into 1 plus r to the power of n minus 1 divided by r, where A is the annual installments, R is rate of return or rate of interest per annum, N is number of years. Present value of annuity is A into 1 minus 1 by 1 plus r to the power of n divided by r. Here again, A is the annual installment. These two are the formulae for calculation of present value and future value of annuity. When we are dealing with annuity due, that means an annuity that starts immediately. It's also called immediate annuity. In that case, the above formula has to be multiplied with 1 plus r for both present value and future value. Now let us see, without using any of this formulae, how we can straight away do this calculation using Excel. Okay, so here is my Excel sheet. My first case is the case of investing 50,000 in a recurring deposit scheme for 6 years, and the scheme offers 9% interest. So my amount of deposit every year, A, which is called as PMT by Excel, is minus 50,000. I'm putting minus because I'm investing. So it's an outflow for me. Rate of interest is 9%. Number of years, N or NPER is 6. The type is annuity due. That means I start investing today. Right now I'm investing, and every year I will be investing 50,000. The future value formula, same what we have seen earlier. Only thing is, in all these cases earlier, we were ignoring an amount, an indicator or an item called PMT. Let us see what happens here. So I'll just start typing the formula is equal to future value, bracket open, rate 9%, comma, number of periods 6, comma, now comes this PMT. This PMT is minus 50,000, comma, we ignore this present value. Then it asks for a type. Type is, we have to type 0 if it happens at the end of the period, or 0 for annuity, 1 if the cash flow starts beginning of the period. 1 is for annuity due. So in our case, we have annuity due. So I'll just type 1 and then close the bracket, enter. So if I invest 50,000 every year in a scheme offering 9% interest for 6 years, at the end of 6 years, I'll be able to get a maturity value of rupees 4,10,021.73. This is how we calculate the future value. Now let's look at the present value situation. So if you look at the annual installment payments for my loan, I'm willing to pay 60,000 every year for the next 8 years to repay my loan, which charges 12% interest. I want to know what is the amount of loan I can take today. If I want to repay a loan completely through 8 equal installments of 60,000, when the bank is charging 12% interest, what is the amount of loan I can take? Here, it is present value, and the nature is annuity because my first installment payment happens at the end of 1 year from now. So let's do it. Equal to PV, bracket open, rate 12%, comma, number of periods 8, comma, PMT minus 60,000. We skip this future value type here. Since annuity, the cash flow starts at the end of 1 year, it is an annuity. So I should put 0, bracket close, enter. So if I want to repay in 8 equal annual installments of rupees 60,000, a loan which charges 12% interest, the loan amount I can avail today, or the maximum amount of loan I can avail today, is 2,98,058.39. The formula that we have used earlier for future value and present value, they are same. Only thing is the PMT amount we were ignoring, we are including that now. And we should also remember that in case of a future value model, we normally don't have a present value. And in case of a present value model, we normally don't have a future value. Okay, so we have seen the formula, the same formula that we have seen earlier. Now, you know that the concept of annuity has many real-life applications like equated monthly installments, monthly income plans, recurring deposits, etc. We will see one by one in the coming sessions and try to understand how the concept of annuity can be applied for valuation of these real-life situations and how Excel can help us in doing those computations. Thank you for watching. I hope you enjoyed watching this video.